Good morning to all. Now next, this is a continuation of the previous one. Now here in this session, we are going to find the Fourier sine transformation of Fourier sine transformation. Find Fourier sine transformation of e power minus as by s. These two problems, this kind of problems are very important to observe. Now, what we have to find Fourier sine transformation of any given domain f of s because of inverse keep constant 2 by pi 0 to infinity f of s into this is sine, therefore sine s t into ds. Now this is equal to 2 by pi integral 0 to infinity e power minus as by s into sine st into ds. Now in the denominator s variable is there, that s variable should be removed. Therefore let the integral be equal to I. Now differentiate the integral with respect to s. Now it will become 2 by pi integral 0 to infinity e power minus as by s. For sign differentiation, that is cos st, s will come out as a constant. Now this s will be cancelled. This is equal to 2 by pi. What we have? Integral 0 to infinity e power minus as into cos s t ds. Now its value equal to 2 by pi of, that is equal to a by s square, a by is respect to s. This will become a by t square plus a square, or this is equal to 2a by pi times t square plus a square. This is f of t. But what we got? Here one more point. With respect to this integral, this is inverse. So the output should be in terms of what? This is not with respect to s, this is with respect to t. Then only s will come out, t will come out. So now this implies this will become di by dt, that is equal to 2a by pi into 1 by t square plus a square. T square by a square. Now just look at, it is in the form of variable separable method. So here di is equal to constant 2a by pi into dt by t square plus a square. Now t square plus a square. Now integrating both sides, we will get I equal to 2a by pi into integral dt by t square plus a square. Now this is equal to 2a by pi, this is integral dx by x square plus a square equal to 1 by a into tan inverse t by a. So this here cancels. This is equal to 2 by pi into tan inverse t by a. This is the output of this function. This is equal to f of t. Now just look at here, whenever there is a s variable in the denominator, differentiate the integral with respect to t, then s variable will come out. Then this s will be cancelled. Then the remaining process is same, just applying the formula, just integrating both sides. Okay. Now let us go for another problem. Now next one, find Fourier sine and Fourier cosine transformations of e power minus at by t. Here one more point. Now either of two, I will make it one problem here. The second problem, students have to make it for your practice purpose. For your practice purpose. Now just look at, now I am finding for Fourier sine transformation of e power minus at by t. Therefore here f of t is equal to e power minus at by t. Minus at by t. Now just look at. Now Fourier sine transformation of any signal or function, that is equal to integral 0 to infinity the function f of t, because it is sine, therefore sine s t into dt, because the output will be in terms of s. Now this is equal to integral 0 to infinity e power minus at by t into sine s t into dt. In the denominator there is t. That t should be removed. That she should be, so let it be I. Say this is equal to I. Now to remove that t, we want a t to come out of this signal, this function signal sin st. Therefore you can make it as di by ds. Then this is equal to e power minus at by t. There is no change in the remaining signal. The remaining signal is integrating with respect to t only. Now just we are differentiating with respect to s to get the t out of that sine signal. E power minus at. So here t will come out. The sin st will become cos st. The remaining everything is same. Now this t will be cancelled. Now this is equal to integral 0 to infinity e power minus at into cos st dt. Into cos st dt. Now this is equal to, applying the formula, direct formula, that is equal to which one? A by s square plus a square. A by s square plus a square. Understanding? T will be cancelled. So here di by ds. This will become di by ds. Now just look at e power 0 to infinity e power minus at cos of st dt. Now here one more point, directly applying the formula, let it be a. This is equal, let it be b. Because of cos, what you are having? A by a square plus b square. A means s square, b means what here? With respect to a square. A by s square plus a square. This is the directly using the formula, given formula. Understanding? Now this value is equal to di by ds. Understanding? Now this is equal to di equal to a into ds by s square plus a square. Understanding? S square by a square. Now this is di. So integrating both sides, this is I, this is a into 1 by a tan inverse s by a cancelled. This is equal to tan inverse s by a. This is what? F of s. This is f of s. So now Fourier sine transformation of this equal to tan inverse s by a. Similarly, students can do the same Fourier cosine transformation. Cosine transformation means here only just in place of sin st, you are supposed to make use of cos st. Here sin st will come, applying the formula. Remaining everything is same. So that problem is left to students. Okay? Left to students. Now these are the problems on Fourier sine and cosine transformations. So next topic is we are using Laplace transformations. As said in the previous one, from Fourier integral concept we are using Fourier transformations. From that we are using Fourier sine transformations and Fourier cosine transformations as well. Now in this one again just we are going to use Laplace transforms. Okay, let us discuss the Laplace transforms. This is the third part of the third unit. Laplace transform. The Laplace transform is denoted by L. Or some others write like this, L, both are same. Laplace transforms. Actually, whether you are using Fourier transformations or Laplace transformations, these are only for continuous time signals. These are only for continuous time signals. These are only for continuous time signals. If you go for Z transforms are for discrete time signals. Discrete time signals. Understanding? So now, whether you are using Fourier transformations or Laplace transformations, these two are only for continuous time signals. If we want to discuss discrete time signals, then we have to use Z transformations. After completion of this unit, we will be entering into Z transformations. Okay? Now let us start. Now, the Laplace transformation of any function or signal f of t equal to integral 0 to infinity f of t into e power minus st into dt. There is no imaginary number. There is no imaginary number. Students have to get it. Understanding? For example, this is Laplace transformation. What is Laplace transformation of 1? For example, look at, in place of f of t, put 1, it become minus st dt. Now, take the integrating constant minus 1 by s. This is n minus t, 0 to infinity. This is minus 1 by s into 0 minus 1. This value equal to 1 by s. Therefore, Laplace transformation of 1 equal to 1 by s, where s is greater than 0. Now look at the formula, Laplace transformation formula. Now look at, what is the Laplace transformation formula of e power at? Laplace means only 0 to infinity. One point students have to remember, Fourier transformations means we have to make minus infinity to infinity. Fourier sine 0 to infinity. Fourier cosine 0 to infinity. Similarly, Laplace is also 0 to infinity. This is equal to applying the formula e power at into e power minus st into dt. Both are exponential functions, signals. It can be written as minus of s minus a t dt. Now direct integrating, the constant is 1 by s minus a. Now e power minus s minus a between 0 to infinity. Just here what we did, only just integrating the exponential function. Now this is equal to minus 1 by s minus a into e power minus infinity minus 1. E power minus infinity value equal to 0. So this is equal to 9 by minus s minus a, 0 minus 1. This is equal to 1 by s minus a, where s is greater than a. Now just look at, now just we started Laplace transformations. In Laplace transformations, the Laplace transformation of any function f of t equal to integral 0 to infinity, that function f of t into e power minus st into dt. Next, Laplace transformation of 1 equal to 1 by s. Laplace transformation of e power at, that equal to 1 by s minus a. Now, the remaining formulas of Laplace transformations and problems on Laplace transformations we will be discussing in the next session. Thank you.